Welcome to you all in my YouTube channel Experience Mathematics. Today in this video I am going to teach you how to solve any linear programming problem using Simplex method. Before starting, I want you to make sure that you please subscribe my channel and press bell icon so that you will be informed about my videos, and I will also be encouraged to make more videos. This linear programming problem can be solved by using graphical method, and we can also solve this linear programming problem by using Simplex method. Okay, how to solve this linear programming problem by using Simplex method? Look at here. For this, we should introduce non-negative slack variables to change this inequality into equations. Okay, so slack variables means that they are the non-negative real numbers, which on adding on the left hand side of this changes into equation. Okay, introducing non-negative slack variables R and S. We have, okay, we will introduce non-negative slack variables R and S. We have here two inequalities, so two slack variables R and S we have introduced. If there are three inequations, we can introduce three non-negative slack variables R, S and T, or any other letters can be used to denote slack variables. Okay, then this above inequality can be written as 2x plus y plus r equals to 40. Similarly, the second one can be written as x plus 2y plus s equals to 50, and this one we can write as minus 5x minus 3y plus z equals to 0. In this way we can write now. This will imply x plus y plus using all the variables r, s and z, we write every equations. So here we can write 1r plus 0s plus 0z equals to 40. In this first equation we have three variables x, y, r and no s and no z, so 0s 0z equals to 40 we wrote. And this second one we can write as x plus 2y plus 0r plus 1s plus 0z equals to 50. And third equation we can write as minus 5x minus 3y plus 0r plus 0s plus 1z equals to 0. In this way we can write these three given equations. And now we will make the Simplex tableau for this. Okay, we can make the simplest tableau for this, and here in one side we write basic variables, and here we write all the variables x, y, r, s, z, and on the right hand side we write these constants. Okay, so here coefficient of x is 2, coefficient of y is 1, coefficient of r is 1, coefficient of s 0, coefficient of z 0, coefficient of x 1, coefficient of y 2, coefficient of r 0, coefficient of s 1, coefficient of z 0, and here on the first equation right hand side is 40, on the second equation right hand side is 50, and here in the bottom here minus 5, coefficient of x, coefficient of y minus 3, coefficient of r 0, coefficient of s coefficient of x minus 5, coefficient of y minus 3, coefficient of r 0, coefficient of s 0, coefficient of z 1, and constant is 0 here. And here this r value is 1, s value is 0, so this r is the basic variable. Similarly, this s value is 1, so this is, and this other value is 0, so it is basic variable. Okay, here 1 0 0 1, so this r and s are basic variable. And here which one is more negative in this bottom row? That column will be pivot column. Okay, so this is here minus 5 is more negative in comparison to minus 3, so this is in this bottom row this minus 5 is more negative in comparison to this minus 3, so this is pivot column. Okay, this column in which the element in the bottom row is more negative, that column is known as pivot column. And now we will take the ratio of the elements in the pivot column with these constants. So 40 over 2 to 20, and 50 over 1 equals to 50, and 20 as 20 is lesser than 50. Okay, so this 20 is obtained from the ratio of this 40 and 2, and this 20 is smaller than 50, so this first row is the from first row we can get pivot element. Okay, so 2 is pivot element, okay, or pivot entry. Like this way you can find out. and we have to make all the elements except pivot element 0 in this pivot column. Except this pivot element, we should make other elements 0. So this pivot element, we should make it 1. Now in R1 divided by 2, what it gives, look at here. We again make a next table. This is the table 1, and we will make table 2. We again write here basic variable x, y, r, s, z, RHS, and as this 2 is the pivot element, then in this pivot column, this x is the entering variable and this r is the departing variable, because x enters here and this r, when x goes here, r departs, r leaves. Okay, so r is the departing variable. So this smallest ratio gives us the row in which we have departing variable. Okay, now dividing this throughout by 2, here will be 1, here will be 1 over 2, this row 1 dividing by 2, this is also 1 over 2, here is 0, here is 0, here 40 divided by 2, it will be 20. And as the element is 1 here, so now x is the entering variable. In place of r, we write here x. Okay, so this the departing variable, this r has left, and this s we write as it is, and s equals s value here is 1. Okay, so x value, x coefficient 1 here, other all numbers we write as it is, 2, 0, 1, 0, 50, and -5, -3, 0, 0, 1, 0. And we also must make this value positive. Okay, so or we should make it 0. So here now R3 plus 5 R, here in this R3 we can add 5 R1 and next to that in R2 we do R2 minus R1, as I have already told that here except pivot element, all elements must be 0. So this one must be made 0, and for that from R2 we subtract this R1, and this also we should make it 0. So for that, from R3 in R3 we add 5 times of this R1. Okay, performing R3 plus 5 R1 and R2 minus R1. Okay, so let's write this table again. Table number 3. Table 3. Basic variable X, Y, R, S, Z, RHS, and here X is 1 over 2, 0, 0, 20, and R2 minus R1, 1 minus 1, 0, 2 minus 1 over 2, let's calculate in rough here on the side. So here 2 minus 1 over 2, that is 2 to the 4 minus 1 over 2, that will be 3 over 2. So here we write 3 over 2. 0 minus 1 over 2, that is minus 1 over 2. 1 minus 0, 1. 0 minus 0, 0. 50 minus 20, it will be 30. And now R3 plus 5 R1. So minus 5 plus 5, here will be 0. Minus 3 plus 5 R1. Minus 3 plus 5 R1, that is 5 times 1 over 2, 5 over 2. Minus 6 plus 5 over 2, that will be minus 1 over 2. So here we have minus 1 over 2, and here 0 plus 5 R1, 0 plus 5 over 2, that is 5 over 2, and 0 plus 5 times 0, that will be 0 again. Here 1 plus 5 times 0, that will be 1 again, and 0 plus 5 times 20, that will be 100 here. Okay, so we have these values in the bottom row. Here 0 plus is minus 5 plus 5 times R1, 5, it will be 0, and minus 3 plus 5 times 1 over 2, R3 plus 5 R1, 0, minus 3 plus 5 times 1 over 2, it will be minus 1 over 2 here. 0 plus 5 times 1 over 2, that will be 5 over 2. 0 plus 5 times 0, 0. 1 plus 5 times 0, 1. 0 plus 5 times 20, 100. Okay, so we have got these elements in the bottom row. Okay, and we should search the most negative number, negative entry in the bottom row, and the column containing most negative entry, that is the pivot column. Okay, so here we have this as the pivot column. In this simplex method, when all the entries in the bottom row are non-negative, then only our work is complete. Okay, till then we should continue the operations. Okay, so this is pivot column, and now the ratio of the elements of the pivot column with the constants we will take, and that smallest ratio gives us the row for the departing variable. Okay, so now let's find out the ratio. Now here 20 divided by 1 over 2, that will be 20 times 2 will be 40, and 30 divided by 3 over 2, that will be 30, times 2 over 3, 3 times 30, that will be 20, that is 20 is smaller than 40. Okay, so this we have obtained from the second row. So the second row is the row containing departing variable. Okay, this S, and this 3 over 2 is the pivot element. Okay, therefore 3 over 2 is the pivot element. 2 is pivot element. Okay, so as I have already said, that pivot element we should make 1, and all the entries except pivot element in the pivot column must be made 0. Okay, so except this pivot element, other element in the column must be made 0, means this 1 over 2 we should make it 0, and this pivot element we should make it 1. Okay, our process is to make pivot element 1 and other element in the pivot column 0. Okay, so we will do that now. So to make this one, we can multiply this row by 2 over 3. R2 we multiply by 2 over 3. Okay, so I have up to here you have understood. Now if you need to copy this, you can pause the video and copy it. I will now proceed to the next step. Okay, now let's move to the next step. Okay, now here also I will write basic variable, basic variables x, y, r, s, z, and right hand side constants, and in the first row we have elements 1, 1 over 2, 1 over 2, 0, 0, and 20, and in second row when you multiply by 2 over 3, here will be 0, here will be 1, and let us do a rough on the right hand side. So that element minus 1 over 2 multiplied by 2 over 3 becomes minus 1 over 3. So we can write here minus 1 over 3, and this 1 multiplied by 2 over 3, that will be 2 over 3, and 0 multiplied by 2 over 3, that will be 0. 30 multiplied by 2 over 3, that will be 20. Okay, that will be 20 here, and in the bottom row all the elements are same. 0, minus 1 over 2, 5 over 2, 0, 1. Okay, we can write like this way. This is table number 4. This is table 4. And now our next work is to make the entry 0 except this pivot element. So here now this is the entering, this y is the entering variable, so we write here y, this y enters, and this another variable s will leave. When it here it becomes 1, then this becomes entering variable here. Okay, so now performing. Okay, so to make this 0, what we can do is we can here R1, in R1 we can do operation R1 minus half of R2. Okay, so here to make 0, so from this half of R2 can be subtracted. Okay, then this will be 0. As I have already told that except the pivot element, all elements in the column must be 0. So to make this 0, from this half we can subtract half of this. Okay, so this operations can be performed. Similarly, here also we will make it 0. For that, with R3 we add half of R2. Okay, so with this, if you add half of R2, then this element becomes 0. Now look at table 5. Okay, now performing these operations, we write this table once again. Basic variables x, y, r, s, z, RHS, x, y, and here from R1, row 1, half of R2 we have to subtract according to this operation. So 1 minus half of 0, that will be 1 again. Half minus half, that will be 0. And 1 over 2, minus half of this 1 over 3, that minus times minus will be plus, 1 over it will be 6, and LCM of 2 and 6 is 6, 2 3 is 6, 3 plus 1, that will be 4 over 6, 2 2 is 4, 2 3 is 6, that will be 2 over 3. So here we have 2 over 3, and again here r1 minus half of this. R1 is 0 minus half of R2 is 2 over 3. So that will be minus 1 over 3. Okay, and 0 minus half of this, that will be 0, and 20 minus half of 20, that will be 10. So here will be 10, and here in the second column you have all elements as it is: 0, 1, minus 1 over 3, 2 over 3, 0, 20, and R3 plus half of R2, 0 plus half of 0, this is also 0, and minus half plus this half, that will be 0, and 5 over 2 minus 1 over 6, that will be 6. 15 minus 1, that will be 14 over 6. 2 7 is 14, 2 3 is 6. Here will be 7 over 3, and 0 plus half of 2 over 3, that will be 1 over 3. So here will be 1 over 3, and 1 plus half of that, that will again be 1, and here we have 100, and 100 plus half of 20, that is 110, and so since all entries in the last row are non-negative, so the optimal solution of the given LP problem is obtained, which is maximum Z equals to 110, 8. This x value is 10, x equals to 10, and y equals to 20, and also the maximum value of Z can be checked by substituting the values of x and y in the objective function max z equals to 5x plus 3y equals to 5 times x value is 10 plus 3 times y value is 20, that will be 50 plus 60, it is 110. Okay, so in this way when we check, then also we have got same value. And the main thing we have to remember in this linear programming problem using simplex method is that we should make here 1001 x value. If we get here 1 and this y value 0 and here y value here 1, then this x value will be 10 and y value will be this 20. And when all elements in the bottom row are non-negative, that means all are non-negative, there are no negative elements, then our solution becomes complete. Okay, and next main thing we have to care is when we make this value 1, then at the time this r will leave, this becomes departing variable and x becomes entering variable, x will come to this r place. Okay, so this x will be written here because we have made this 1, so this will come to this place. So that thing we have to care. And next thing we have to care is x, this is the pivot element, and except pivot element, other element in the pivot column must be made 0. So this is this should be made 1, we have made it 1, and except this other element in the column we have made it 0. Okay, so the main idea is this one. In this simplex method we have to find out a pivot column, and we have to find out pivot element. Okay, and after finding out pivot element, that pivot element, if it is not 1, we should make that 1, and except that element, all elements we should make it 0, and in the bottom row elements that should be non-zero, and when bottom elements become non-zero, then our process completes. In this way, using simplex method, we can solve the linear programming problem. Okay, so I hope this video is helpful to you. Thank you for watching, and if you have not subscribed my channel, please subscribe my channel and encourage me to make more videos, and also press bell icon so that you will be informed about my coming videos. And if you need to copy it, then you can pause the video and copy it. I will display this last page also once again. You can pause the video and copy it if you need to copy it. Otherwise, if you understood the concept completely, then you can also do it yourself. Okay, if you just know the process for one problem, then we don't have any specific formula here. Other problems can also be done similarly, and this is useful for class 12 in group C. If you just know how to solve one question, then remaining questions you can try yourself. Thank you for watching once again. Thank you very much.